Okay, today we will discuss about SystemVerilog. Before that, what is the main difference between the Verilog and SystemVerilog? See, Verilog is used for designed purpose. Okay, whatever the hardware you want to design, okay, so that will go with RTL. So whatever the RTL you want to design, so that will be designed with Verilog. Okay, Verilog is the language is used to design the RTL or hardware or any digital circuit, um, whatever the thing you want to design through RTL only, through Verilog only we are designing this. Okay, and then system Verilog, what is the main difference in the Verilog and system Verilog is, so Verilog is only used for RTL design. System Verilog is used to design the RTL and verify the RTL. Okay, so for verification also we are using this system Verilog. Okay, so it is used to design the RTL as well as verify the RTL. And then different topics will be there. System Verilog is not a new language. Okay, it is the combination of all the different languages like Verilog is there. Okay, it will support the wire data type and reg data type, and then logic also supports here. Okay, so different data types will be there. That means two state data types are there, and then four state data types are there. In system Verilog, two states and four states are there. In Verilog, only two states data type will be there. Okay, only two states are there. That is the one difference. And then in system Verilog, OOPS concept will be supporting. Okay, it supports that OOPS concept like inheritance, okay, polymorphism, and then some classes. So classes topics are also there. See, in Verilog, we will design the one hardware by using one module, right? Okay. Inside the module, another module you want to represent means that is illegal. So Verilog doesn't allow one module inside the other module. Okay, that is not allowed. But OOPS can allow one class is there, inside that another class will be also there. Okay, this is your base class, and then some child classes are also allowed here. Okay, so that is the see from one base class. Okay, this is my base class. From this base class, I will extend. Okay, I will extend many classes. Many classes I will extend here. Okay, whatever the different classes are there, all the things I will extend here. And then data types, according to the data type, only net type and reg type only available in the net type and reg type only available in Verilog. But here two state data types are there, and then four state data types are also there. Okay, all these are main differences while coming from the Verilog to system Verilog. Okay, so in system Verilog, these are the data types. Okay, what is the use of data type? Okay, data type is used to store the values. Okay, why we go for the data types means what is the reason we are using the data types means what are the data types are there, all are used to store the values. Okay, used to store the values because we are driving the stimulus to your DUT. Okay, whatever the stimulus you are driving to the DUT, that will be having some values. Okay, those values can be stored by using different variables. A is my variable, B is my variable, C is my variable, or some identifiers you learned in Verilog, right? Suppose some variable array is there. Okay, so this is my variable name, or gnvt is there. Okay, this is my variable. Okay, these variables can store any type of values. Okay, that is the reason we are going for the data types. Okay, data types can store the variables. Can Data types are having the variables or identifiers. that can store different values. Okay. See, these are the different type of data types, two-state data types, and then four-state data types, signed, unsigned, and literals. Some constants we are using. After that, variables. Okay, and then constants we are going to discuss here. These are the different integer data types like integer, int, integer, shortint, longint, bit, byte, logic, range, time. All these are integer data types, like it will store values here. Okay, and then real, short real, and then valid data type, strong data type. Okay, sorry, valid void data type, and string data type, events. So these are the different data types we are using related to some integer data types, all these things. And user defined data types are also there. Some typedef is a user defined data type, and enumeration and logic data type. Okay, so all these are different data types we will discuss one by one. Okay, what is two-state data types? Two states means we are having only 0 or 1. Okay, and it does not allow any unknown values here. Okay, it does not allow any unknown values and high impedance values here. Okay, so because these 0 or 1 we are using like a digital switch. Okay, this is the best for digital switches because it will operates on two states only, 0 or 1. I think we are going for on or off, so that's why it is best for digital switch. Okay, so it's best for digital switch because only two states are there means memory is less. Okay, memory is less, and then power consumption is also less. Okay, whatever the power we are using, that power consumption is also um, less for two state data types. Okay, so power consumption is also less for two state data types. That is the main thing why we are using the two state data type. Two-state data types means it is operating fast and less memory is used, and better for verification models because unknown values and then high impedance values are not there means it will be verified easily. Okay, so these are the two-state data types. In this two-state data types, bit, byte, and then integer. Okay, all these all are available for two-state data type. Bit bit is a two-state data type. What is the default value of bit here is, so default value of bit is 0. Okay, it cannot avoid and assign any value. Then the default value of this one is 0. In this bit we are having single bit variable, and then vector type bit is also available. Okay, so this vector type means 3 down to 0 is there, that is 4 bits are using. Okay, so this 4 bits means how many values are producing means 2 power 4, that means 16 values are producing, right? So bit is an example for two-state data type. Here I'm just writing simple code to represent a bit variable. So I have taken two stimuluses here, two checkers here. Okay, A and B. Okay, so A is a single bit variable and B is a 4-bit variable. Hello, are you there? Yeah, are you there, guys? Any disturbance is there? Just give me a minute. I got the power. Okay. So just I will turn it on to Wi-Fi. Already connected Wi-Fi. Okay, fine. Hmm. Yeah, tell me what you are asking. Anything you are asking? So this is the bit data type. For this, how we are representing the code for bit data type. So just single bit variable we are taking, and then 4-bit variable we have considered. Okay, so single bit, only one bit can be stored either 0 or 1. Okay, so that's why a equal to 1 we are giving the stimulus, and then b equal to b is a 4-bit variable. That means it can store this is the size of my number, and then this is the base, and then 1011 I'm giving here. Okay, in this way the data will be stored. Okay, you can give b equal to 1 4 tick b 10 1000 you can give, or b equal to 4 tick b 1001 you can give. Any type of data you can give. That is the possibility of 4 bit. So 4 bit means up to 0000 to 16 bits it is possible to store. Clear? And then what is the important topic here? We don't have in the two-state data type cannot hold that range and unknown value and high impedance value. Okay, if we are assigning anything means, okay, it will becomes to 0. Okay, you are getting 0 value only. That means a equal to 1 tick bx you are giving means your output should be a equal to 0 only you are getting. Okay, so that is the important thing. If you assign unknown values to two-state data types, okay, it will store 0 only, because unknown values are don't considered in the two-state data type. Okay, in the four-state data types you are having four states like 0 state, 1 state, and then unknown. High impedance also it is supporting that. Okay, 0 1 unknown value and high impedance also supports in four-state data types. That's why it can store more values, and also power is also high. Okay, so and then logic data type. You know what is the difference between the logic data type here? Logic we are using that in verilog we have two data types are there. One is net type data type, and then reg type. So this net is used for continuous assignments. Okay, whatever the continuous assignments are there, so whatever the combinational circuits are there, okay, all are continuous assignments. For that we are using net type data type. And then reg type, it is a procedural assignments. Okay, so procedural assignments means we can use always and then initial begin. Inside the always and initial begin, we are using these procedural assignments. Okay, so that means reg type data types can store some values because of we are having some storage for that. Reg is a storage type of data type. That is the reason maximum we are using the procedural data type. See, but in net type, whatever the net type is there, whatever the input ports are there, okay, all input ports we are using wire type data type. That is the continuous assignment. And then whatever the outputs you are having, so you are using reg type data type. That is the sequential assignments. But I don't know, here the output we are having the reg type in the RTL. So in RTL perspective, whatever the inputs we are using, wire type we are implementing, whatever the outputs are there, reg type we are implementing. But it is dealing with the DUT is dealing with the outside the world. Outside world means inside the world means input ports, whatever the input ports are there in DUT inside world, we are using wire type only. But it is dealing with the outside world. Okay, reg type it is using. Okay, so that is the reason why. So I don't know, it is taking the reg type or wire type. At that time we will go for the logic data type. Clear? So logic data type, it can be stored wire type of data type, and then it can be whenever wire required, it will be act like a wire. Whenever register data type required, it will be act like a register. That means logic can store both the continuous and then procedural assignments. Okay, whatever the procedural assignments we are going for assigning for the input and output registers. Okay, so at that time we will go for continuous type of procedural assignments. Instead of that, we will go for logic. Okay, are you getting me, guys? Hmm. Okay, so that is the main difference, logic and then wire range. Wire and range, wire is used for continuous type of assignment, range is used for procedural assignment. But I don't know, whenever we need required continuous assignment and range type of assignments, that means procedural type of assignments, at that time logic we can use. This logic can apply both continuous assignments and procedural assignments. Okay, it will support both. That is the reason we go for the logic. So here logic we can assign, logic is a 4 state data type. Okay, in this we can also use a single variable can store, or vector also it can store. Okay, this is the 4-bit vector is there, and then this is the single bit variable. Here it will supports unknown value, and then high impedance values are also it will support. Okay, whatever the input we are giving, that will be stored here. Okay, so unsigned and unsigned. So signed means what? Signed variable means it will support both the positive values and negative values. Suppose you are taking some integer type or logic. Suppose I have taken logic signed. Logic signed means here I am having 4-bit. So 4-bit means 2 power 4. What is the capability of producing values is 16, right? So this 16 will be coming from 2 power n minus 1. So now we will discuss about, just give me a minute. So now we will discuss about signed number and unsigned data type. Signed data type and unsigned data type. Here signed means only positive values can be stored here. Sorry, positive and negative values in the sign means. Okay, it will store positive and negative. Suppose I am using 4-bit binary here. Okay, 4-bit data type I am using. Logic is my data type. 4-bit variable I am using here. 2 power 4 means 16 is there. Okay, in this 16, how it can be stored means minus 8 to plus 7 it is storing that. That means 2 minus 2 power n minus 2 power n minus 1 to, okay, so plus 2 power n minus 1. Okay, in this way it is supporting that 2 power n minus 1 minus 2 power n minus 1 to minus plus 2 power n minus 1 minus 1. See, minus 2 power n is the 4-bit, right? 2 power 4 minus 1 to 2 power 4 minus 1 minus 1. Okay, minus 2 power 3 to 2 power 3 minus 1. That means minus 8 to plus 7 it can be supporting. Up to 15 values, it is 16 values it can be support. Okay, minus 8 to plus 7 means 16 values. That is the reason we go for the signed numbers. Okay, whatever the range we have, that will be divided into two parts. One is positive part and other one is negative part. Okay, so unsigned means all are positive values. See, in our verilog and then system verilog, all the values are taken defaultly unsigned numbers. Okay, all are positive values only we are taking. If you want to represent your data type with signed values, then you can go for the signed data type. Okay, so that is the reason. See, all are taking like positive values only. Okay, so sometimes we want to represent some unsigned values or signed values explicitly. You need to mention, so what type of data type you want to be get some positive values and negative values, and what are the data types you want to get only positive values. It can be represented normally. Okay, that is the signed and unsigned numbers. This is the example for signed and unsigned. Okay, how it is representing the bits here. Okay, see, so these are the bits I am having. Module, um, some, what is that, module signed demo. I'm having 4-bit binary number, 4-bit logic data type. It is signed, and then 4-bit logic data type without signed. Okay, signed values can be stored. This negative value, how it is representing in the verilog. See, negative means this -3 will be represent, minus means negative sign. Okay, in the MSB bit we will represent -1 here. Okay, after that 3 means 0 double 1 we can represent. Okay, but whatever the number we have, we need to get the complement of this one. Okay, 100, so 2's complement type we can represent. This is the 1's complement number. Okay, 1's complement means wherever you are having 0, that should be converted to 1, and wherever you are having 1, that should be converted to 0. Then you can ask me why this 1 is not converted. This is the signed magnitude. Okay, signed magnitude cannot be converted for 1's complement and 2's complement. We are keeping this negative, means minus 1 is keeping same at the MSB position. Then 1101 is the number we are representing. So that is the 13. So -4 in 2's complement form, we will get 13 here. Okay, so in that way we will represent, and then so the value will be taking like 13 we will get. Okay, and then so here also we will get that unsigned value. Okay, so that will be getting -13. Okay, and variables. What are variables? Variables during runtime, it is changing continuously. Whatever the variables, see, because all are variables, right? A is a variable, B is a variable. So these variables will be changes, because every time delay we are giving some values. See how the RAM is there. In that RAM, whatever the data we are storing, that will be changing. Clear? My screen is visible, right, all of you? Hello. Ah, okay. So variables can change the values during runtime. Okay, during runtime it is changing. See, I'm taking count here. So this count may be changes. See, count equal to 10, I'm taking count equal to 20, I'm taking. After time, some time delay, I'm going for count equal to some 30 also I will take that, and you can display that dollar display whatever the count you can write, so that will be right here, and you will get the output. Okay, here you will get 20, here you will get 10, and here you will get 30 output here. Okay, that is the reason. Or whatever the variable, suppose not only count here, you can take any variable like a can take. So then a equal to 10, I'm displaying the a value, and then a equal to some 20 I'm taking, and then I will display this. Okay, dollar display, I'm taking the value a equal to some percentile d, and then a I'm written here, and then after some time delay, so 20 seconds delay, I'm changing my a value, some 35 I'm giving. Again I will write the dollar display, Okay, so every time you need, this variable value will be changing. Okay, so that is the reason we are giving the variables, and then all the variables can store different values. Okay. So in this, what we are having integer data types. Next one, what are the integer data types? Integer data types are used for mainly arithmetic operation, addition, subtraction, multiplication, division, whatever the arithmetic operations we are going for that integer data type we are using. So integer is a two-state data type. Okay, so two-state data type we are using. Okay, that is the int we are having. Int is different and integer is different. Integer is a four-state data type. Whenever you are loop count using for loop counting purpose, we are using this integer x. Okay, integer some I, that is the integer. Okay, but here int means that is a two-state data type. In this int we are having shortint and then longint also. So shortint, it will store 16 bit. Okay, it will store 16 bits, and then longint, it will store 64 bit, and then integer, it will store 32 bit. Okay, so integer is a two-state data type. It can store 32 bit. It is a signed data type. Signed data type means, see here, 2 power minus 2 power 32 minus 1 down to, okay, 2 power 32 minus 1 minus 1. In this way the range will be splitting here. Okay, so that is the formula for signed value. See, minus 2 power 31 to, okay, plus 2 power 31 minus 1. Up to this range of values it will be supporting for this integer data type. Okay, so integer can be stored any type, any data type. Okay, so signed data type, that means it will store the both the positive values and negative values. See, int a I am taking a equal to minus 25, it will be displaying here. Okay, how the minus 25, I told you, right? Minus means negative sign, that whatever the most significant bit is there, this is the MSB bit. In this MSB bit you need to represent 1 here. Okay, and then 2 5 you can take, 25 you can take, that magnitude you need to represent. After that 2's complement will be considered here. Clear? Okay. So integer is a older type of Verilog type. Okay, it is a 32-bit data type. It will support four-state data type. So where we are using this integer means, suppose I'm using for loop. In the for loop, what is the representation? I equal to 0, and then I greater than, I less than 10, I plus plus. In this way we will represent, right? Before that, we will take the data type integer, and integer I can take that. Then only this for loop will be executing. Otherwise, you can also write for int I equal to 0, I less than 10, and I plus plus. In this way also we can write. Okay. See, just he's taking integer x and then initialize to some unknown value and displayed that one. So unknown value will get that, because it is supporting four state values. Okay, it will produce both the zero state value, one value, and then unknown value and high impedance value also. It is producing that. And then shortint is a 16-bit register. Okay, 16-bit integer type of data type. Okay, this 16-bit, so it is also signed data type, because integer is a signed data type, shortint also integer signed data type, and then longint also signed data type. Okay, shortint, it can be stored, what is the range? So 3 to 768. How it is representing? See, minus 2 power 16 minus 1 down, 1 down to plus 2 power 16 minus 1 minus 1. Okay, this is the range. Okay, 2 power minus 15. 2 power minus 15 means, 2 power 10 means what is the value? 1024. 2 power 11 means 2048. 2 power 12 means okay 4096. Okay, so in this way 2 power 13 means okay 80 something, and 2 power 14 means 16, and 2 power 15 means 32. Okay, 32767, that is 768 to 32767 range we are writing the short int data type. The long int means 64 bit. So that means 2 power 64 minus 1 down to minus 2 power 64 1 down to 1 minus 1 down to 2 power 64 minus 1 minus 1. This much range values you need to store. This is huge number, right? So that is the long int we are using. Yeah, long int is used for large counters and then timestamps, whatever the addressings we are using. At that time, long integer we are using. Okay, and then byte is a two-state data type. Okay, it will store both the signed values and unsigned values also. Okay, byte is a signed data type. In this signed data type, it will store both the negative values and the positive values also. Maximum byte is used for packet type of devices. Okay, some see, I'm using single byte, a single bit we are using here, and then byte some 7 down to 0, and then C I can use. Okay, it will support up to 8 means 2 power 8 values. 2 power 8 means 256, right? That means minus 128 to plus 127, it will support that. So that is the byte representation. Okay, so it will take any type of value. See, it is storing some string, so ASCII values are also storing that. That means strings also stored by using byte. Okay, so that is the use of byte here. And then time. So time is unsigned data type. It can be stored. What is so where we are using the time means I want to go for current simulation time. What is the current simulation time I need to represent? For that, we go for the time. Dollar time we are using that. Okay, see, start t equal to dollar time I'm representing here. So what is my timestamp here? Time is a data type, and then my variable is start underscore t. So that will be storing here. After 20 seconds delay, I'm displaying the time. Time equal to percentage 0t. Okay, what is that? Dollar time. Dollar time hyphen timestamp. Okay, so then my time is that. Okay, what is the time I'm getting here? Dollar time equal to 20 seconds I'm getting here. So that is the reason we are going for the dollar time. Dollar time is used for at what time you are executing your statements. Okay, what is the delay you are considering? Suppose another delay 40 seconds I have written, then dollar display you can write that. Okay, so my time is equals to percentage 0t. Okay, dollar time you can write that dollar time, and then start t. Okay, so in this way I have start represented means here I am getting 40 nanoseconds delay here. Okay, that is my output. Okay, what is the current simulation time we want to print in your output side? That is used for, that is going to use it for dollar time. Okay, that is the timestamp we are using that. And then strings. String is a collection of different characters, right? So what are the characters we are having that will be stored in the string? Okay, so module, some string demo. What is the name? So strings can be stored names, names of your data types. Okay, whatever the name you are using, that will store here. Okay, name is my data type name. Okay, so variable name, that is the variable name it can store. SystemVerilog is the string. Okay, dollar display name you can write that. And here name comma language also I am representing. Okay, what is my name? SystemVerilog, and I am using here concatenation operation. Okay, concatenation operation, it will combine the two variables. Like what is the other name I am getting here? SystemVerilog language I'm getting because the name is SystemVerilog. Okay, so and then concatenation we are using that language. Okay, these two are getting together and displayed at the output side. That is the see string operations. There are too many operations are there. We will discuss in the further classes. Okay, string having some inbuilt methods length you can find. Okay, in the string that means what is the my string length? That means here system verilog is there. How many letters are there? That length it can be printing. Okay, and then name size you can represent that, and some index letters you can also get that. So get and put methods we are using, and also I'm getting like two upper and two lower. That means whatever that variable your name you are using, okay, in string name you are using, right? That name all are connected to upper letters. That is two upper we are using. Okay, all these things we will discuss later. Not a problem. Just you need to know what is the string. String is a collection of group of characters or collection of characters. Okay, it will store some names on your variables. Okay, whatever the variable you are taking, that will store names. Clear? Any doubt in this? Up to this strings, and then what are the time? Sorry. Okay. Yeah, yeah, I will explain. Okay, byte is a signed data type. Okay, it will store 8 bits values. That is the reason we are going for the byte here. See, byte is a signed data type. Signed data type means it can be stored both the positive values and negative values. Okay, so and also it can useful for ASCII values, like it can store some characters, okay, names, whatever the variables you are using. Okay, that variables is capable to store some ASCII values. Okay, so ASCII values have nothing but characters, right? What are the characters you want to write? That will be stored in the byte format. And then some packet types, packet bytes means group of bytes of different bytes of data I'm storing, that will be supported here. So byte is a 8-bit signed data type. Okay, 8-bit means how many values it will be getting? 2 power 8. 2 power 8 means 256 values we are getting. Then it is a signed data type. Okay, it will support from minus 2 power 8 minus 1 down to 2 power 8 minus 1 minus 1. That means minus 128 to plus 127 values it will be supporting that. Okay, that is the byte data type. Clear? So see, byte is a variable here I am taking. That variable can drive the any string data type or number or name. Okay, anything it can be support here. C equal to 10 also I can give that. C equal to some verilog also I can give that. Okay, it will support to store that. ASCII values are also storing to supposed to store. Clear? Any doubt in this? Okay. So time and then all these things. String also can store the group of characters. Okay. So that is the string we are using. And event. What is the event? Why we are using in events in our system Verilog means. So event is generally used for synchronizing purpose. That means we are using different processes. Okay, in that I want to execute one process at a time. At that time we will go for event here. Okay, so event one time it is triggering the value, and other time it will be executing. Okay, see here one process signal and another process will be waiting. That means one process is triggering the event, it will trigger the event. Okay, whenever it is triggering, it another process is waiting for that. Okay, waits for that whenever it is triggering, and then it is executing. That is the event process here. Where we are using these events means, suppose they are asking, I want to execute three processes. Okay, we have five processes in your code. Okay, so in that only I want to execute three processes, and remaining processes I don't want to execute it. Okay, at that time we will go for this events type of modeling. Okay, see, module event demo, I'm taking done here. Done is the event done here. This done is my variable name. This is the triggering value here. Okay, see, two variables we are using. That means hash hyphen implies here. Okay, so this is like a arrow marker. Okay, arrow symbol is there. This is the triggering, this is used for triggering purpose. Okay, it will trigger the event. Okay, whatever the event we are having, that will be triggered here. My event name is done. Okay, done is triggered here. After that, wherever the done is there, that will be executing here. Okay, see, here I'm using done. Okay, it will be waiting for that. Suppose I'm waiting for that, so at the rate wait, you can use that wait done equal to 3. Okay, wait for that. How many three processes are completed or not? It will be wait for that. After that, it will be executing exit from the loop. Okay, up to that, it will be in the loop only. Okay, so it is triggering the event here. Okay, so by using implication operator, we are using that. Okay, this implication operator will tells you that triggering is done here. Based on the triggering, it is executing in the next cycle. Okay, so because triggering is already done and waiting for the triggering, this event when it is executing means it is waiting for the triggering. Then whenever it is triggered, then it will be executing. That is the reason we are using the event here. So event is generally used for synchronizing purpose. Okay, one process is executed and the other process will be waiting state. Okay, so that is the purpose we are going for event. And then typedef. Okay, typedef is a user defined data type. Okay, so user can store this data type. That means user may be use different data types by his own names. Suppose typedef is the my data type. Okay, so by using this one, I am representing int here. Okay, int is a typedef data type. For that, my int I am using. Then this my int is my user defined name. Okay, this my int also act like a, it is also act like a integer data type. Okay, whatever the integer data type we are taking, so this my int is also act like a integer data type. Suppose I am taking typedef. Okay, typedef byte I am taking byte. This byte will be, I'm having some name, verilog. Okay, so this verilog name is also act like a byte. Okay, user can define. Okay, so create custom type names like nicknames, whatever the nicknames you have. Okay, that will be represented by using typedef. Okay, typedef is a user defined data type. This is the typedef. Here I am using any type of, suppose I am utilizing logic. Okay, typedef logic I have utilized. In this logic, whatever I am representing the variable, Baba I am representing. Okay, so this Baba is a logic data type. Now you can take this Baba as a logic data type, and then Baba 1, Baba 2, Baba 3, Baba 4. In this way, you can represent different data types. All these are act like a logic data type. Okay, so where you are using b1, that is also act like a logic, b2 that is also act like a logic, and b3, so that is also act like a logic. Okay, that is the reason we are going for typedef. Okay, so typedef is a user defined data type. Whatever the variables you are representing, that will be act like a some data type. Based on that, we can create n number of data types here. Okay, if you are confusing about the data type names, then go for the type def. Okay, based on the type def, any data type, whatever the data type you want to represent, you can represent that. Suppose byte I am representing here, then you can represent the byte value. By bit I am representing here, you can represent the bit. Okay, whatever the variables you are taking, so this a I am taking, that a will be act like a bit, then a1, a2, a3, a4, different bit data types I am creating here. Okay, that is the user defined data type. Okay, in this real, short real, and then void type, string, event. Okay, all these are different data types are there. Okay, so I think short real and void data type we are not discussed. Event already discussed about it here. Okay, string can be collection of different data types, and different and string can be collection of variables here or characters. Okay, and event is the synchronizing purpose we are using, so it is triggering. It is also explained here, and user defined data type we have already explained here. Then go for the real and short real. Okay, a real data type, what is the use of this one? Real can store, it is a posted data type here. So this is the real can store floating values like 0.0 or 1.2 or 2 5.3 or 5.2 5.3. Okay, these values can be stored by using this real data type. Okay, real data type can store decimal values. Whatever the decimal values we have, it will be storing here. Okay, see, real can be used that some double precision floating points. Double precision floating point means so whatever the floating values we are having, right? That will be storing here. So not only single floating value, that means 1.2 is a single, and then 1.2345. So that is the double floating values. Okay, it can be stored. It can be capable to store floating values also. The default value of this one is 0.0. That is the default. If you are not giving any value, then the default value it will be storing like 0.0. Okay, see here pi is a variable. This pi is repeating, right? 3.1415923. So these values will be repeating up to the infinity values. Okay, it is not never ending. Pi is never ending the process, so it is 24 by 7. Okay, so this 24 by 7, it is not 24 by 7 or 22 by 7. Pi is what is the value? 32 by 7, right? Okay, anyway, pi's can be stored some infinity values, right? So 3.14 means I think 22 by 7 is the value. Okay, so 3 times 21. Okay, so 1 is there, and then 1 time 3 is there, 28, 4. So in this way, okay, 22 by 7, pi is the value. Okay, whatever it may be that pi value, so it will be storing up to the infinity values that can be stored by using real data type. Okay, so in this real, short real, and then long real also there. Okay, real time also there. Okay, this real time is also stores that, see what is the time we are using. For time, it will store the current simulation time. Whatever the current simulation time we are executing, that will store. That is the timestamp we are using that. Similarly, real time. Real time is also used to store the current simulation time, but with floating values. Okay, what is the simulation time we are having? That will be stored with floating values. Suppose hash 1.2 you are using, or hash 10.5 you are using, or hash okay 22.20.10 you are using. Okay, based on that it will be storing. That is the real time we are using that. So real time it can be stored. Real is the default value is 0 here, and real time is the 0.0 something we can store here. Okay, the current simulation time we are having. So here also 0.0. Okay, that is whenever you are not assigning any value, then it will be storing that default value. Okay, shortreal is that that is also precision values it will be stored. That means here double precision values are there, but shortreal is single precision values will be storing here. Okay, so single precision values means only can store point 0.1 point 0.2 point 0.3, so up to that it will store that. So after that decimal value it will store single floating value or single precision value. That means 1.2, 1.3, 1.4 or 10.1, 10.2 or 100.2. Okay, in this way it will be storing that. Clear? Real time, why we go for the real time, it will be storing t equal to 10.5. So this t1 equal to 10.5, suppose I'm not representing the delay here, so delays are representing like this, hash 10 or hash 20. Okay, in this way we will represent, but sometimes I will also represent hash clock period. Okay, whatever the clock period I'm having, that will be representing here. Okay, based on that clock period, suppose clock period is representing some value, like clock period equal to some timestamp by whatever the time you are taking, by time by 2 I'm taking that. So this time or this clock period is depends upon some address width. Okay, so address width by 2, based on that different values will be producing. That is the reason we go for some variables in the timestamps. Okay, see here you can change time value t1 here, this timestamp also changing here. You are using t1 equal to some 100.2, then your delay will also change here. Then your current simulation time, what is the current simulation time, it will be displayed by using this real time. Okay, but it can store some point values also, precision values also it can store. So what is the use of void function? What is the main difference between the function and function void? Okay, every time in SystemVerilog we are using this void. Suppose I'm using the method call, this is my method function void display, I'm using this. Okay, it is only used for storage purpose only or display purpose only. It does not return any value. Okay, return type is no return value is there. Okay, no return value or no return type is there. Okay, return type is not there in function void. Okay, void doesn't return any value. Okay, there is no return type here. So generally how we are representing the method means, this is my function name called new. In this some integer a and b you can represent that. After that y equal to, I'm taking that a y equal to a plus b I'm writing, then return y. Okay, this y value will be written here. Okay, that will not be available in function void display. Okay, this void cannot return any data type or cannot return any value. There is no return value here. That is the reason we are using void data type. Many times we will write function void or void. It will be taking that. Virtual function void, you can take that. Function void, you can take that. A pure virtual function void, you can take that. any void is there means, so this void doesn't return any value. That is the reason we go for the void here. Okay, any doubt in this? Clear? So enum data type. Enum is a enumeration data type. I will explain this separately. Just go through this enum data type. Enum is also named states. Okay, named constants we are having. Enum is used to store named constants. What are the named constants we have? Okay, it will be stored that named constants. Like suppose enum I am taking here. Okay, some enum is a data type. In this, some names you can write. So A1 is the name, and A2 is the other name, and A3 is the name. Okay, so A4, or you can use some names like fruits names like apple. Okay, so and then orange. Okay, whatever the names you can take, you can consider by using name enum data type. So named constant we are having. This is the name. Okay, for this default values are stored like 0, 1, 2, 3. In this way, the default values will be stored because it is automatically incrementing the value. Okay, whatever the value we have, okay, automatically incrementing the previous value. Whatever the previous value you have, okay, that will be automatically incremented. Okay, so that means you are having some name value. See, red is that having some 5, and then you are assigned some values in between that. Okay, so whatever the next letter is there or next name is there, that will be incremented automatically 5, and then next becomes 6. Okay, green is 8, and then orange is having orange color is having some 9 here. Okay, because the previous value, whatever the previous value is there, then the next value is incrementing by automatically incrementing by +1. Okay, that is the reason we are taking the enum data type. So enum data type is a named constant values. Okay, so that will be store some values names. Okay, in this I'm using some name, and then here also some inbuilt methods are there. First method, last method, and then next, and previous. Different methods are there. Okay, you can use these methods to represent values. Like suppose I'm taking A1 is my name, and so or V is my name, and then L is another name, and then N is another name, and then G is the another name. Okay, so V, L, and G is the different names I'm using that. Here 0, 1, 2, 3. If you are not assigning any value, it will be automatically takes that index values. This is the 0th index, first index, second index, third index. In that way, it is taking that. Otherwise, we can mention that V is equals to 10 and L is equals to 5. Okay, so automatically increment value, right? So it can be taking the increment value, or you can assign any value. And N is I'm not assigning that, and G is the 20. So then N value will becomes the 16 here because automatically incrementing that. Other, if you are assigning any incrementing value for the existing variable name, then it gives the syntax error. Like see, compilation error will get that. So v is equals to 10 I'm giving, then here 11 we are getting, but n is equals to 11 I'm assigned here. Then what else? L is also getting 11, right? But this is not supporting by using enum data type. Okay. So just it can store the named constant values red, yellow, green. I'm taking that. By using this handle, we can call it. Why we are using this handle means, so because this handle will tells you this is like a suitcase, right? So while carrying this suitcase by with handle only, okay, in this suitcase different things are there. I am not carrying all these things, just I am carrying the handle, then all these things are come along with this handle, right? That is the reason we are using this handle. Traffic T is that handle I am utilizing. Then it will come that, see, signal equal to red. Signal is my name. Okay, traffic signal, traffic is the handle. Then that for that handle I am representing one variable signal. That signal is representing red. Okay, so then it is getting the red value. That means signal dot name, because by name only I'm calling, right? So that is the name. So there is inbuilt methods. Name is also another inbuilt method. So name you can write that, and then values are also you can write that. Okay, I will explain the enumeration data type code, okay, separately. And then logic data type I have explained, right? Why we go for the logic data type, what is the reason for logic data type, all these things. Okay, logic is a logic is used for when procedural assignments and continuous assignments are needed. At that time, we go for the logic data type. I don't know when we need logic procedural assignment, when we need some continuous assignment. I don't know what type of thing it is taking means. Then I go with logic data type. Okay, so logic clock and logic data. So this data will be incrementing for every clockage of data, clockage of for every clockage. Okay, clear? So these are the real-time industry uses of different data types. Okay, so this will be type where we are using logic type and use it for logic. When you are using the logic means RTL resist RTL signals. That means whenever you are representing input and output ports in your RTL, we can go for this logic only. So because logic can be avoiding the conflict between the range and wire. When you are using the range and when we are using the wire, okay, this conflict will be resolved here, okay, by using logic. And then bit. So bit can be used for almost most of the time in the verification variable we are using that bit only, because bit is used for fastest verification. See, in your test bench time, your test bench is used for verification. Most of the times they are using rand bit. Okay, so rand bit I'm using that. And rand bit there is a vector represented 7 down to 0a, or some 15 down to 0b, or rand bit, okay, some 31 down to 0c. In this way it is utilized because it will store either 0 or 1. There is no other values for this. That's why bit is used for verification variable. Okay, most of the time enum and typedef. Okay, if you want to reuse the code or fsm finite state machines we are using, at that time enum I'm utilizing that. Enum most of the times we will go for the finite state machines. Okay, whatever the finite state machines we have, that will all representing. See, we have some states like current state, like input or idle condition, start condition, and then address condition, address state. After that, some acknowledgement, and then data state. After that, acknowledgement state. In this way, different states are there in your FSM means at that time I will use enum data type. Clear? And string is used for storage for different messages printing. Okay, that messages printing, UVM messages always printing purpose, string we can use. Okay, dollar $s format s, they are using that dollar $s s format f. Okay, this can be used for $f format s is used for converting one type of data type to other data type. Most of the UVMs we are using this one. Okay, during UVM time you can use this one. At that time, I want to represent the string messages, some UVM info messages I want to print that, or warning messages I want to print that. That's the purpose string is used there. Okay. And event synchronization purpose, I told you most of the time synchronizing purpose means I'm utilizing different what it called different processes. In that few processes only I want to execute it. At that time this event data type is used. And typedef reusable code. Reusable code means I told you typedef is a user defined data type. If you are using some int type data type, int a I am using that, then user can define int data types a1, a2, a3. So this int I want to use anywhere. So and then most of the times I'm using this integer data type. That is the reason I'm utilizing this type def. By using this type def, we can call a1, a2, a3, a4, a5, a6 up to and so on. So any number of data types you can represent that. That will be supporting by using type def. And then time and real time. Okay, so time and real time is used for representing the current simulation time. What is my current simulation time is there. Okay, so I want to display the current simulation time at the output side. I will go for this time. Real time is also same thing, but it will store some floating values. Okay, 12.5, okay, 13.5. In this way the values will be stored here. So basically timing analysis purpose we are using this time or real time. Okay. See, all these are different data types we have explained. Okay. Any doubts up to this, all of you?